Hello, sir. Hello.
Yes, hello.
Hello, bro.
So the quiz two is covered five.
Yeah, basically we are going to take previous year question and solve each question, and we will revise the both concept with the help of that question.
What I am asking quiz two in exam, it is covered 5, 6, 7, 8 weeks only, correct?
Yes, mostly,
Thank you.
but there are some one two question from week 1 to
Week one also.
week 1 to 4. Yeah, there's some very few.
So mostly 1 to 8, correct?
Mostly
5 to 8.
five,
Mostly
but
5 to 8.
Thank you.
I think we can start the session now.
so let me share the screen. My screen is visible. So my screen is visible or not? Tell me. Hello.
Yes, sir.
My screen is visible or not?
Yes. It's showing the visible.
So share the video. So I'm starting the session, okay?
Yes.
So as I said earlier that I am going to take previous year question, and with the help of that question we will brush up our topic. So let's start with the first question. Okay. Have anybody solved this question earlier? This question? Hello.
Anybody solved this question before? It's a DS mode probably. Alok sir, continue this session.
Okay, so let me start. So basically, in this question, we have to find the first the transformation. So here it has given that the domain is R square. So and we are taking the image in R, basically one dimension. So so first we have to find the linear transformation. It has given that this line. The trace of this transformation is basically linear transformation will be given by the trace of A. So basically, what is trace of A? So trace of any matrix is the sum of its diagonal. Okay, everybody know that. Sum of its diagonal. So can we write simply this transformation as Txy is simply x plus y because xy is diagonal here. So can we write x plus y diagonal element? Is this fine?
Yes, sir.
Okay. So we know that linear transformation. So linear transformation, we know that Tx comma y is x plus y. Now we have to find two things. First is injective and second is surjective. First is injective and second is surjective. Since the transformation is quite simple, very simple transformation, that is mapping R square vector in 2 dimension to the vector in 1 dimension. So we don't intuitively we can find. We don't have to look for the matrix, and when we calculate rank and then nullity, we don't have to look over that. Why? Because we know that injective is what? Basically, for injective, we can directly compute that T of B is 0. So V should be unique, simply. If this condition satisfied, then we can say that the transformation is injective. This point clear or not? This is very important. That if suppose we take we take the transformation of a vector and applicate the 0 vector, and then if this vector is unique, so only one vector. If only one vector exists that have zero zero vector in the transformation, so then we can say that V is basically this transformation is injective. So let's find. So if I say that Tv of V is equal to 0, then can we write this as x plus y is also 0? Can we write it or not?
Yes, we can.
Okay, so x plus y is equal to 0. It means that x is equal to minus y. Now, it means it is saying that if x plus y have to be 0, then x and y should have same value, but basically negative of each other. It means we can take 2 comma minus 2, then basically also 0, 3 comma minus 3, then also 0. Basically, we are getting a bunch of vector. We are basically getting a line. X is equal to minus y, a line. And so this doesn't satisfy the injective condition. What I say earlier, that if the function have to be injective, then if Tv is equal to 0, then V also must be equal to 0. V must also equal to 0, then injective condition satisfied. But here 2 comma minus 2 also brings 0, 3 comma minus 3 also gives 0, and any pair of x comma minus y will give 0. So I don't think this is injective. I looking at the rules of the injective, like if Tv is equal to 0, then V should is equal to 0, V must equal to 0, then injective. So this is not injective. So this is the condition that you have to check for the injective. So any doubt in the checking of injective for linear transformation? Any doubt in checking injection?
Yes, sir, it's clear.
Okay, so we can say that T is not injective. Now second point is surjective. So basically it's like function. So if you the image of the projection like x plus y, So this is the basically if the image of the linear transformation matches the codomain. Here codomain is what? This space R. Same like Maths 1. So it's simply a scalar number. So I think with x plus y, with the x plus y, we can get all the real number, all the set of real number. Basically, x plus y can get me all the set of real number. It means that the function is basically linear transformation is a surjective function but not injective function. So we have taken from here we can know two conditions. First is injective. When the transformation will be injective, suppose a TB of that we check, we put B and we see 0, and if only one vector, that is B, must be equal to 0. If this condition satisfied, then we will say injective. And what the condition of subjective? The condition of subjective is that the image, the codomain must be equal to the image. So here we can see that the x plus y can span all the codomain. So P is basically a surjective but not injective. And what is bijective? If both surjective and injective, then we call it bijective. But here is no point. And then we also call isomorphism. If the function a transformation is bijective, then we also call isomorphism. So it's not isomorphism.
Hello, sir. One
Yes,
minute.
yes.
I think the surjective is codomain equal to range, correct?
Yes, so you can say that image also. Range and image both are same.
So image means what is the element in domain that is known as image, correct?
No, I don't think so.
Okay, correct. It's a pre-image in domain. Okay, thank you, sir.
Yes. So you can check injective, surjective, and if both, then it is called bijective, and isomorphism, both are two same things. So I think this option is correct. And in later part of the question, we will see how to check injective and surjective with the matrices. Because this question is quite simple, so we don't have to take matrix. But there are questions where you have to calculate matrix to know the injective and surjective of the function. So we will look at it. Okay, now the second question is basically we have to find it is given this is matrix P and this is matrix Q, and say that A is 2 cross 2 matrix and can be written as B is equal to PAQ. So we have to know that.
Excuse me, sir.
Yes.
Sir, I'm really sorry, but I just joined the session 2 minutes ago, and due to which before that I was having some network issues, so I was unable to understand the question 1. Could you please explain it?
Okay. So
Thank you, sir.
1 second. The question is saying that we have to write linear transformation. Like linear transformation is given by the space of A, basically sum of diagonal of A. So we write first transformation, and we need to check that this transformation is injective or surjective. So for the condition for injective is this one, and the condition for surjective is this one. And basically condition is TV if you take the transformation of any vector and result in 0, so this vector must be equal to 0, and this is the condition for injective, and this is while loop, because any pair of x comma minus y will become 0. So this condition value is it means that the transformation is not injective, and same for codomain. Codomain, if you take the x plus y, then it span all the basically x plus y will span all the codomain. So it is subjective function. I hope it's clear. So second question, we need to check whether B and A are similar or equivalent matrix. So simple condition. So what is equivalent matrix and what is similar matrix? Let's look at. So suppose B is equal to PAQ, and if P and Q are inverse of each other, then we can say that matrix is similar. If P and Q are inverse of each other, it means we can write B as P inverse A P, like this. Then we can say that matrix is similar. And if rank of A and rank of V is equal, then we can say that matrix is equivalent. Matrix is equivalent. Simple condition to check. Okay. So we have given two matrices A and B. If we check that if A and B, the rank of those matrices are is equal, then matrix is equivalent. And if P and Q are inverse of each other, then we can say that basically inverse matrix. Then we can say that P and A are similar.
So 1 minute
Yes.
here.
Yes.
But here P is a n into n matrix and Q is a m into n matrix. N into n matrix. The dimension is different, correct? As per the lecture.
Which one? Yes.
This
Basically,
here.
similar matrix.
Then
Any
how-
square matrix. Any square matrix can be similar matrix, and the equivalent matrix can be m cross n matrix. Yes.
No, here A is m into n matrix.
In
P is m into n matrix. M into m. Q is n into m. Correct? As per lecture, it was mentioned like that only.
no, I didn't mention order basically. Where I mention order of the matrices. No.
No, it has to be invertible. That means equivalent matrix.
In this question you are taking. In this question,
Okay.
you are talking about this question.
Yeah, correct. Okay, sorry.
So I didn't mention order. So basically, obviously, if matrix is similar, then it must be any square matrix can be similar, not any rectangular. So and rank of if so these two are the conditions for similar and equivalent, I think. So now check in this question. If P and Q is inverse, then we can say that B and A are similar. And if P and if the rank of P and rank of Q is equal, then we can say that the matrix is equivalent. But the catch is any similar matrix can be equivalent matrix. Why? Suppose B is equal to P inverse AP. If this condition satisfied, it means the B and A are similar matrix. So we can also basically B is equal to P inverse AP. So this is the condition for similarity. So we can say that B and A are similar, then we can also say that B and A are equivalent. It means all similar matrices are equivalent matrices, but not reverse is not true. So you directly check P and Q are inverse of each other or not. How to check inverse? Basically, if you multiply those matrices, two matrices, and you get identity matrix, then it means P and Q are inverse of each other. So you can directly multiply those two matrices and see whether you get identity matrix or not. So understand the condition of similar matrix and equivalent matrix.
Yes, sir.
So can you try? Can you multiply matrices P and Q and check whether this result in identity matrix or not? Please multiply. Like I am also going to multiply here. So P and Q, multiply with me on your copy. So 1, 3, 4.
Yes, sir. It's identity.
It's identity, no. So you know matrix multiplication, so I'm not going to use that. So it's identity matrix. It means if identity matrix, then it means then B is equal to I can write Q inverse A P. Sorry, A Q. What? So we can basically we know P and Q are inverse of each other. So if this is identity matrix, if this is similar matrix, then it will also be equivalent matrix. So there are no doubt about it. And if you want to verify, so you cannot calculate the rank because A and B are not given. Okay. So A and B are similar matrix. You can directly say that. And A and B are also equivalent matrix. So A and B are not equivalent matrix is wrong because A and B are also equivalent matrix. Okay. Now one more thing about equivalent and similar. So similar matrix. So pattern of the question in the Q2 will also be the same, like repetitive question come along. So similar matrix. If two matrices are similar, then they have same determinant. This is also common. And trace and eigenvalue. So this is not just know this as a fact. Nobody is going to ask. So determinant, trace, and eigenvalue, and then you have same rank. So these are the properties of similar matrix, not the condition. Property. If two matrices have same determinant, same trace, same eigenvalue, same rank, can we say that it is similar matrix? No. These are the property of the similar matrix, not the condition to validate that two matrices are similar or not. Okay. So, and what about equivalent matrix? So any matrix, two matrix with same rank. If the rank of two matrices, matrix A and rank of two matrices are same, then we can say that these two matrices are equivalent. So this is a condition. Rank, if two matrices have same rank, then the matrix will be equivalent. So this is not the property. This is condition. So you can check that if two matrices have same rank, then it will be equivalent matrix. Okay, so I hope equivalent and similar clear. Okay. So any doubt in question number 2?
Sir, how can we find the inverse of 3 by 3 or 4 by 4 matrix?
So that's you will not, like in mostly in Q2 you will not find that question. You have to find inverse. That's highest good problem. So you can refer them. So nobody is going to ask the inverse of any matrix.
Okay.
But you can check, like if someone claiming that these two matrices are inverse of each other, then you can basically multiply those matrices and check whether it is identity matrix or not. So as in this case, I return and we do and find the question answer. Now the third question. Can we move to the third question?
Yes, sir.
Yes, sir, we can move.
So
Okay.
1 minute.
Yes.
What is the trace in that matrix? Matrix. What is mean by trace in matrix?
Trace means sum of the element in the diagonal. Suppose this is diagonal. Okay. This is suppose I have matrix 3, 4, minus 4. Okay. And what is diagonal element? This one and this one. And you add those elements, 3 plus 3. So that is trace. This 6 is trace.
Sir, if we talk about diagonal elements, so
Yeah.
trace is only for square matrices, na?
Exactly. Yes. So let's start this question, third question. So it is telling that we have to check the matrix is vector space. Which of the vector spaces are isomorphic to R square? So what is isomorphic? As I discussed in question number 1. Anybody?
Sir, subjective and injective both.
Okay. And suppose if a function is suppose injective, if a function is injective, then what can we, if not function, if a linear transformation is injective, then what can we say about nullity of T? Nullity of T is what?
Sir, nullity should be 0.
And what about
0.
If a transformation is surjective, what about its rank of transformation?
Rank
Sir,
should be
full
n.
rank, sir.
Rank.
Full rank, sir.
Not full rank. Rank should be the dimension of the codomain.
Sir, I just want to know the dimension of codomain is n only, no?
What?
Dimension of the codomain is n, right?
No. It's depend on the question. Like n is variable. So suppose I am taking
Or we can say number of column.
suppose there is transformation from A to B. Okay, so A is also vector space and B is also subspace. Now I am saying that if the rank of T is equal to the dimension of B. If B is R, then dimension is 1. If R square, the dimension is 2. R cubed, the dimension is 3. If the rank of this linear transformation is equal to dimension of the codomain, then we can say that the linear transformation is surjective. Understood?
Yes, sir.
Rank basically.
Yes.
So let me explain it is. Let me explain simply. So suppose we have given a transformation T A. Okay, we have given transformation where A is the domain, subspace, and B is the subspace spanned by codomain. Okay. Now for each linear transformation, suppose A has alpha as order basis, like alpha 1, whatever, alpha 1, alpha 2, and alpha 3. Okay. Now beta has also B, basically codomain also order basis B, beta. So beta 1, beta 2 to beta n. So, and it is beta n. So it have n dimension and it have m dimension. Okay. We know that for any ordered basis of domain and codomain, we can write a matrix. We know, right? For a linear transformation, for alpha and beta ordered basis, we can write a matrix for this linear transformation.
Yes, we can.
Yes. Okay. So if we can write matrix, suppose we name this matrix, I'm going to name K, and this is going to K. And if so, I write matrix somehow. We will see this question where we have to write the matrix of linear transformation, and we will get to know that how we can write the matrix for linear transformation. So I'm assuming that I can write somehow. Okay. And I know if we have given a matrix, okay, then I can easily compute its rank and its nullity or null space. So the rank of this matrix K will be rank of T. We know that, and the nullity of this matrix K will be nullity of rank, nullity of T. Okay. So here I am saying that a rank of T and nullity of T. Then what we are saying? Basically, we are talking about this matrix. That's why I take the example come here to explain what this rank and nullity means. Okay. So there is example. There is question 5 or 6 question. So from there we can create a matrix and we can find rank and nullity. So as far as this question concerned, you can just remember that this matrix for a particular linear transformation we have a matrix, and the matrix and the rank of this matrix is equal to the rank of, we can say that interchangeably, rank of this matrix or rank of this transformation. Nullity of this matrix, nullity of this transformation means the same, not the second thing. So we know that if nullity of T is 0, then function is injective, and if rank of T is equal to rank of T is equal to dimension of B, basically codomain, then the function is surjective. If we combine these two conditions, then we can get the function bijective function. Bijective function. If we can combine those two conditions, we get bijective function. Okay. And from rank nullity theorem, we know that rank of T plus dimension, rank of T and nullity of T is equal to dimension of A. A is basically this. A is basically the dimension of the domain. So dimension of it. So nullity of T is 0.
Sorry for
And
the
rank,
interruption.
yes.
Sir, there is some background disturbance, so could you please check that once?
No, I don't. My side?
Yeah, it's from your side.
Still?
Yeah, I think it's from the fan.
Let me check.
बैकग्राउंड म्यूजिक किसी कौन है क्या भाई?
Now it's okay.
आलोक भाई बैकग्राउंड
Sir,
म्यूजिक
now
ऑन
the
होगा क्या?
background music is there.
I don't think he can control that, so let it be.
No,
फैन ऑन कर लो
I
आप.
don't. I
आप
don't
फैन
know.
ऑन कर लो, म्यूजिक कम ही हो जाएगा उससे.
Okay. Now it's clear. Hello.
No, it's not, but we can work with
No,
it.
sir. It's still hearing.
Like it's the background music coming from 200 meters or 100 meters, you can say. So I can't control it.
हाँ सर, इट्स
And sir, it's
मैनेजेबल
still
मैनेजेबल
there.
सर. कंटिन्यू सर.
So where was I? So this is this part. So I am just saying that if rank of t, if function 2 be the injective, then the nullity of t must be 0, and if function 2 be surjective, then rank of t will be dimension of t, basically dimension of codomain. This part clear or not?
Yeah.
Okay.
Yes, sir.
And from rank nullity theorem, we know that nullity of t and rank of t is what? Dimension of a, basically dimension of this domain. So we know that if it combine for bijective or isomorphic, nullity of t must be 0 and rank of t must be equal to dimension of b. So can we say that dimension of a and dimension of b must be equal for a function to be bijective? It means if you are projecting from 3-dimensional space to 2-dimensional space, there will be not a bijective transformation, linear transformation. If you want the transformation to be isomorphic, then dimension of both the spaces, domain and codomain, must be equal. Is this clear or not?
Yes sir.
Dimension of B
Yes,
must
sir.
be equal to dimension of A. So we
Yes.
have to apply this concept in this question.
Sir, how we can find the dimension of B and dimension of C? The question.
Okay, from the question.
Okay, sir.
You have given a specific question, like in this question. If this question are saying that which of the following vector spaces are isomorphic to R square, isomorphic to R square. So we have to take, suppose R square considered as a domain, and these are B1, B2, and B3. There are 5 options. So I'm taking B1, B3, B4, B5. These are 5 spaces, and from these spaces we have to find that which that B1, B2, B3, B4, B5, which will be isomorphic to R square. So basically R square have dimension 2. You know that. So if any those this vector space, that is 5 vector space we are given, if any vector space will have dimension 2, then these two will be isomorphic to each other.
Or sir, if there are cube, like we are finding the dimensions by the square, by the exponent, right?
No, yes, in general, if R vector in Rn, then it must have n dimension.
Okay, sir. That's why I'm just curious about that.
Okay, so basically, two vector spaces are said to be isomorphic. Okay, so basically, I'm saying that if dimension of domain must be equal to dimension of codomain, then the the two vector spaces we can define a linear transformation that is isomorphic between two vector spaces. But it's not guaranteed. This question, if you apply this concept in this question, it will work. Okay. So basically, check which vector spaces have 2 dimensions. Basically, if the domain which is given R square have 2 dimensions, then codomain also have to be 2 dimensional. Now for this vector space, if this vector space have 2 dimensions, tell me. This vector space have 2 dimensions. Check number of independent variable. So number of independent variable will define the number of dimensions. How many independent variable, like condition given this vector space is telling what? X by z belongs to Rq such that x plus y plus z is equal to 0. So any vector in this space must satisfy these conditions. So we can write as minus y plus z. So here y and z are independent. I can take any value of y and z and when we get the x. So y and z are independent, isn't it? Is this clear or not? How to find dimension of this vector space?
Yes, Yes, sir. So like we have to put the x value, which is equals to minus bracket y plus z into the quotient, into that quotient where it is written x plus y plus z. At the place of x, we have to write that x. We have to write the
No.
expression
We,
that
we
you
have to
have
simply
raised.
see this condition. So it is saying
Yes.
that this vector space is saying that any vector which satisfy this condition, like if you sum three vector, like if in R3, and if you sum three component like a x component and y component and z component, and you get zero, then that vector will be in this vector space. So all sort of vector, if you add those x and y and z component and you get zero, then that vector will be in this space. So I'm saying that what are the dimension of that vector space? So dimension will be basically two, because we have two independent. We have two x plus y plus z is equal to 0. So we have two independent variable. Like the y and z can be determined by anything. You can determine by, you can put y and z anything, but x should be the sum of negative of the sum of y and z. That's why I'm saying y and z should be
Okay,
anything.
sir.
So that's why the dimension is 2,
Uh,
because
so
y and
how
z can be anything.
so how are you identifying that x is equals to minus y plus z?
From here, this
You-
condition is given now. Any vector which satisfies this condition will be in the vector space, this condition. And I am making all those RHS. I am sending all those y plus z in basically RHS. Y plus z. This is 0.
So one more question. If
Yes.
we have if we have constant like 2x plus 2y plus z, and then another constant, so how we can find it? How many
That
what is the dimension of the equation?
so 2x plus 2y plus 2z is equal to some constant supposed to. And then
Yes,
what?
sir.
Then what? The next. Okay, I have to find the dimension of this.
Yes, sir.
So basically, I can write x plus y plus z is equal to. Okay, no. So this will be not a subspace, because subspace must contain 0, comma 0. And if we choose 0, comma 0, and if I put 2, 0, 2 by 2z, so 0 plus 0 plus 0 not equal to 10. Okay, so any
Yes, sir.
vector space must contain 0 vector. So 0, there is no 0 vector, so we cannot find. Basically, this is a finite space, not a subspace.
Okay. Or sir, if we have like minus 10 or plus 10 before the equal sign in this equation, then still we will not be able to find that dimension, right?
What? Okay, you are saying minus 10.
No, sir, minus 10 before the equal sign.
Okay, minus 10 and then, oh, okay,
Minus 10 then equals to 0.
2x plus 2y plus 2z minus 10 is equal to like this.
Yes, yes, sir.
So you when you shift this in the RHS side, then you will get 20. Still you can't get 0. So for a vector space or subspace, there should be a 0 vector. You cannot get suppose 0, comma 0, and you put this vector in this condition.
I'm sorry. Sir. I'm sorry. If we have plus 10 here, rather than minus 10, if we have plus 10, then it
Okay.
will become 0.
Then it will become 0, so no point of having. So nonsense. This condition
Okay.
basically. So okay. So so everyone recognize that this have two. This vector space will have two dimension. Have two dimension. Any doubt in this?
How
Tell me,
are
get
you
me the.
coming to the conclusion of that it has two dimensions? Sorry, my concept was a little weak, so if you could
Okay.
explain.
So, do you understand this vector space saying what? Saying that
Yeah, I understand that
this
part.
will satisfy this condition. Okay.
If we are just assuming, right? X
No,
plus y plus
not
z.
assuming. This is given. This condition. This is condition. You're saying
Okay.
this condition.
Okay.
Now.
Yeah, I'm seeing.
Okay, so can we write this basically like this? We are shifting all sum of y and z to the RHS side.
Okay.
Is this right? Is this right?
Yeah.
Now you can say that. Can we say that we can y and z, basically y and z. So x basically this x will be the sum of y and z. Can we say that negative of basically x will be, there is a constraint on x. X cannot be any arbitrary value. for this equation. X will be always be what? What will be the y? What will be the z? You add both and take negative. That will be x.
Okay.
Understand this one? It means x is not independent. Getting this point? X is not independent. I cannot determine x. I cannot set x is equal to 10. Why? Because x is equal to 10. If we say that x is equal to 10, then this condition will violate because y and z, x will be always the sum of y and z, and if you take negative, basically negative of y and z.
Okay.
Okay, so x is dependent on y and z. Did you like? Did you understand that?
Understood. So it has
Now,
to be.
okay. Now look at that. Is there a condition on y and z that y should be this, y should be z, y should be this value, or z should be this value? Is there any condition?
No.
No. So y and z are independent. So y and z can be
Oh,
like y.
got it.
Any
So
arbitrary
we have
value can
two
be put
independent
into y.
variable, one dependent variable. So
Okay. So
two,
number of independent variable is basically dimension.
Understood.
Okay. So that's why I'm saying that the rank, so dimension of this waiver is 2.
Sir,
Yes.
sir, can you please once again show how to check isomorphism on R2, which you have explained before explaining this sum?
Okay. Isomorphism. Okay. Isomorphism means bijective function. The linear transformation. I'm telling function just understand is linear transformation. So linear transformation is injective and surjective. In both, then isomorphic. Now injective is the nullity of this condition is satisfied, then injective, and if basically this condition satisfied, dimension of D basically codomain basically, then it is surjective. If you combine these two conditions, then you get, if you combine these two conditions, then you will arrive at this dimension of codomain and dimension of domain must be equal for isomorphic. This part you are saying dimension of codomain and dimension of domain must be equal for linear transformation to be isomorphic.
Yes.
So now look at this condition. This is domain, okay, and I have to find the codomain which will be isomorphic to this domain. So this is dimension 2 because any Rn vector, Rn vector will have dimension n. So any R2 have dimension 2. Then I have to find from option which vector space have dimension 2. So from the first option, I can basically I calculated that dimension of this is also. So these two are basically these two are isomorphic to each other.
Yes, sir. Understood. Thank you.
Okay. Now the second part. Now just check the what dimension. This is saying that V2 is spanned by this vector, and this vector. Now check if this dimension is 2. How to check this dimension is 2? How to check the vector have how many dimensions? So basically, you just put it in.
Sir, in first, how we concluded that is isomorphism just because of dimension in first question?
Yes, just because of dimension. We are not checking injective and subjective individually. Why? Because we don't know the transformation. We don't know the linear transformation. So how we can check injective and subjective individually? That's why I'm directly checking. Yes.
So in that type of question, we check the dimension.
No, this type of question, but it doesn't mean that any transformation with R squared to Rn, basically same dimension will be directly a isomorphic. We don't claim that dimension of domain and dimension of codomain, then this will be a basically isomorphic. But for this question, I am saying that. But this is the least condition. Basically, we are talking about the least condition. If Rn to Rn, then this is the least condition. If if linear transformation have to be isomorphic, then the dimension of domain and dimension of codomain must be equal. This is the least condition. Okay, because we haven't given anything here, no? We have given the domain, dimension of domain 2. Then what we have left? We can just apply least condition. What dimension of domain is 2, then dimension of codomain also be 2. And we are calculating on the dimension of codomain. Assuming this is V1 is codomain, then I am calculating dimension of it. If it is 2, then I will say that this is isomorphic. And I will calculate here also dimension. Getting my point?
So Alok, just one follow-up question.
Yes.
So in this scenario, if the condition is x minus y minus z, then if it moves to other side, it will become plus, right?
X minus y plus z.
No, no, x minus y minus z. Like
Yes,
convert
yes, yes,
all the plus
yes.
into minus.
It's equal to 0.
Then it goes. Then x will become y plus z, right?
Yes, so still y and z are
Again, it's
independent.
dependent. Again, it's
Again,
dependent.
yes, we can determine y and z any arbitrary value, but x will be always be determined by y and z. So x is dependent and y and z are independent. Yes. So still the dimension is 2.
So if this condition only will be false if there was only x minus y, and it would have gone on that side, then we got up only got one dependency, and that would be rank one. So, right?
I didn't get it.
No, so I'm trying to figure out in what condition that first option will be wrong. So if, I'm saying that if it was x minus y equals to 0.
No. On what condition? This is x plus y plus z is equal to 0. And
What
it
if
is
it
also
was
given
x
that
minus y?
x minus y is also equal to 0.
Yeah.
So if this condition and this condition both are given, then if you like x is equal to y and here x is equal to minus y plus z. Now check number of independent variable.
No. So in this, so, forget like x plus
Z
y plus
minus
z.
y.
Just x minus y. Okay. Only this was the condition given. If in that scenario, then it would have become x equals to y. Then y is dependent on x and x is dependent on y. So in that
X minus
condition,
y condition will given this condition.
uh,
Then x is equal to y. And z can vary with value. So z is just still independent, and y is also independent because y or x you can say that. What can if you say that y is independent, then x will be dependent. If you
again
say
we
that
got
x is
two ranks. Yeah.
independent, then y is dependent. So both in both ways the dimension will be 2. Because z you can take the value of z anything.
And can you move to that v2 equals to span, which you are going to explain?
Okay. So v2 the span of v2. So vector space
So one more question.
Yes. Yes.
Sir, is it important to write x is equals to like y minus z or something? So, or we can switch with the variables. We can sometimes do it like y is equals to x minus z, something like this. Or is it important to only write with x?
No, this is a specific question this is given. Doesn't mean all question will be like this. So don't try to remember the question. Remember the concept. So x plus y plus z is equal to 0, then
No, sir. I'm
yes.
saying, no, sir.
Yes.
I'm just saying.
Yes.
You have given us so many examples, right?
Okay.
With this equation. I'm just saying here we use x, but can we use sometime another variable like y and z, or is it important to only use the first variable like as we have x here? This is
Okay,
what
so
I'm
here
asking.
is x, then here is of yx. What that's what you are asking. If this is x, then y this is also x. Can we here other than x? That's what you are saying.
No, sir. I'm not saying this. I'm just saying, like this expression, we have
Yes,
x
Aisha,
plus y plus z.
you can do that. You just have to check the condition if these are mutually dependent. Okay, so that is just the
Yes.
condition. So they are mutually
Okay.
dependent. Y is dependent on x, x is dependent on y. That's the only thing
So
which you have.
we can like in this as the sir have told us, we can do it like x is equals to minus something like that. So we can switch with any variable. Like we
Yeah,
can
you
do
can do
y,
that. If
we can do
z equals to x
yes.
plus minus xy, again it will become interdependent between z
Yeah,
and
that's
x.
what I was asking.
Yeah,
Either we can switch with the variables or we have to stuck with the first variable.
you just have
Yeah.
to check the
Oh,
dependency.
okay. You are
Oh,
saying that instead of like you will write x plus z.
yes, sir, that was yeah.
Instead of this.
Yes.
No point.
Still we
No,
can.
all these are same. Like these are like
Yeah.
similar.
Yes. Yes.
So if you I'm talking about this, then this is no granted. Take it for granted.
Okay. Thank you.
Now second one. So we have given three vector that is 1 0 1 0 1 0 1 0 1. So there are for checking these three vector have how many dimensions or this space have how many dimensions? We have different method. So don't like put any constraint on like but we have to go through different like method for solving this. Like we have given three vector. Now we want to know that if this three vector is independent, then we can say the dimension will be what? If I'm claiming that these three vectors are independent, the dimension of V2 will be what? Anybody?
Sir, 3.
So yes, 3. But I don't know that these 3 are independent or not. Then how we are going to check that? Just put into the matrix. So put this matrix 1 0 1. Now put this matrix 1 1 0. Now put this vector. Put this vector in. Then put this. Then put this. Now convert into reducible form. And now what? Now calculate rank. And if rank of this matrix is equal to column of this matrix, then all vector are independent. Okay. So now convert into reduce row echelon form. This matrix. So is this matrix is in row echelon form? No, because look at this condition. This is array one. So not echelon form. Look, like how to convert this matrix into row echelon form?
R3 minus R1.
Okay.
So by either doing R3 minus R1 or like R2 minus
So
R3 minus R2.
So I will get 1 minus 1 0, 0 minus 1 minus 1, and 1 minus 0. Basically, what? 1. Right? Is right. Yes, right. So 0 1. Now subtract R3 with R2. Then we will get 1 1 0, 0 1 1. Now 0 0 and 2. Now if this is row echelon form. Yes, look at this matrix. This matrix actually is like this. 1 0 0 and 1 1 0 and 0 1. Now tell me, this is this matrix is in row echelon form. Tell me. Yes or no?
I guess no, because we still have to. It has to be bottom has to be completely 0, right?
No.
It is in row echelon form.
Yeah, it is in
row
that
form.
triangle form. Okay.
Basically, every column has this. Basically, here this
Yeah.
column is 0, and this is 0, and this is nothing. So no matter. So now look at the pivot. So column 1 has this pivot, and this is also pivot, and this is also pivot. Okay. So we have total number of pivot is 3. If we have total number of pivot is 3, it means we have rank 3. And we have rank 3. Rank 3 is equal to what? And we have also column 3. First column, second column, third column. So we have rank 3 and the column is also 3. It means you can say that all these three vectors which are span V2 will be independent.
For a row echelon form, it should be upper triangular matrix. Am I right, sir?
For a row echelon form, it should be upper triangular matrix. Yes. So here it's not upper triangular.
Okay.
So that matrix was also. So what? There is 0, then 1, and then 0, then 2, and then 1, 0, something like that. So this is also in a pattern. This is a diagonal, and this all part lower. This is of 0. So this is called upper triangular matrix. Isn't it?
Yes.
So the dimension is basically 3, and here we do have dimension 3, but we require dimension 2 for isomorphic. So this plane is also. So this is not isomorphic. Now jump to the third option. So you can calculate that. I'm not going to. And it must try this question, because in each option you will have different method for calculating dimension. Basically, you will encounter different, like first bar different, second bar different, and third will be also different, and the fourth one is same, fourth one is same, and the fifth one is same. Like first, second, and third is different, totally different. So this is matrices. This is matrix space, not a normal vector space. So you have to calculate dimension of this matrix. So anybody know how to calculate dimension of this matrix, or skip this part, because all this is the content of big 4 1 to 4. Calculating basis and dimension, all those.
We need to check the number of free variables.
Okay, yes, exactly. Like this. Like where this condition a plus b is equal to 0. Can we write a is equal to minus b and c plus d is equal to 0, c minus d is equal to minus d? If a plus b 0, then I can derive this, I can derive this. So in the place of b, I can put, sorry, in the place of, okay, in the place of a, I can put minus b, and in the place of c, I can put minus d, and here a and b. So how many independent variables? Only two.
So 2.
So dimension is 2. So it is also isomorphic. Okay, get that. Now look at before. So before is saying that x is equal to 0 where a is 0. So basically x is belong to R3. Basically x is telling null space of this matrix. Null space of this matrix. Null space of this matrix. So what I have done in the question number in the option B2, just convert this matrix into I and calculate the nullity of this A, null space of A. And if null space of A is 2, then it will be in row echelon form. So how to calculate null space? Basically, what will be the rank as I calculated earlier? The rank, subtract rank from this column. Subtract rank from this column. Like if this is 3 and your rank is 1, so 3 minus 1 is 2. And so null space is also, so this will be a isomorphic. I'm assuming that. How to calculate null space, nullity of this, you know, matrix. So in the V2, tell me, in the option number V2, what is the null space of this matrix? Null space of this matrix basically. If I this matrix, what is the null space of V2? Anybody?
0.
Yes. This basically column is 3 and rank is over 3 minus 3 is 0. So it have only 0 subspace. Now similarly for V4 you can do that and you can calculate, and for V5 you have to calculate like 5, 2 minus 3 and 1. So column of space of the matrix is 1. Basically you have to calculate rank of this matrix, and if the rank of this matrix you have to done the same method as I have done in V2. So and if this basis, if the dimension is 2, then you can say that it is isomorphic, and it is isomorphic according to this question. Okay. Now question 3. There doubt in this question? Anybody have doubt in this question?
No, we can.
Okay. So question number.
Continue, sir.
Question number. So select row statement. So analyze one row. Whatever. So what this is saying? For the matrix A of dimension m cross n, the rank of matrix is equal to minimum of m or n. No, listen. So if this is matrix A, so if you want to calculate the rank of matrix, rank of A, okay, rank of A, the rank of A is always less than minimum of m or n. M or n is basically m cross n if matrix has m cross n. Then rank of A will be always be less than equal to minimum of m or n. Suppose you have 2 cross 3 matrix, the rank will be always be less than equal to 2, because minimum of 2 and 3 is 2, so rank will be always less than equal to 2. Either you have 0, 1 or 2 rank. Getting my point? So rank of A is always less than equal to minimum of m or n. If suppose 3 cross 4 matrix, will be minimum of 3 cross 3 or 4 is what 3. The rank will be always be either 0, 1, 2 and 3. Now he's saying that in this question he's saying that for a matrix A of dimension m cross n, matrix is equal to the rank of the matrix is equal to the minimum of m cross n. No, this is inequality condition, not equality condition. So this is if minimum of m not equal to minimum of m or n. Suppose minimum of m of n is 3, it might be 0, 1 or 2, any rank. And secondly, nullity of the invertible matrix is also 0. Basically, invertible matrix is what? Invertible matrix, it means the column will be independent. Column will be independent means rank will be equal to column of A, and the column, if the rank is column equal to column of A, then null dimension of null space is 1, 0. Dimension of null space is 0. Okay.
Sir, for the first option, can we say it is maximum of M1n
What?
For the first option, can we
Yes.
say it is the a maximum of M and N, the rank?
The rank of A is equal to maximum of M1. No. Rank, you cannot put condition on rank of A. Equality on rank of A. Rank of A will be equal to this or that. I am saying this is inequality condition. Rank of A less than equal to minimum of M or N. Okay. Suppose if you have given matrix A is 3 cross 4. Okay. And you have to find rank of it. What are the possible value that rank can take? So rank of it will be always equal to less than equal to minimum of M or N. M or N what? M is 3 and N is 4. So minimum of 3 or 4 what? 3. The rank of A will be either 0, 1, 2, or 3. These are the value that the rank of A can take if the matrix is of order 3 plus 4. This is the inequality condition, not equality condition. Getting my point?
Okay, thank you. I understood.
Now, second. Nullity of invertible matrix is always 0. Nullity of invertible matrix is always 0. So yes. So if any invertible matrix, then rank of that matrix is equal to column of A, and the null space contains 0 vector. So nullity will be 0. So nullity of invertible matrix is always 0. It means null space of that any invertible matrix will span only 0 subspace, nothing else. Now third. For a matrix A of dimension implosion, the row space of A is same as the column space of A. No, dimension of row space of A is equal to dimension of column space of A. But the row space and column space are two different. So suppose this is matrix. Okay. So suppose this is matrix 1, 2, and 1, 2, 3, 4. Okay. So the claim is that the point is that the dimension of this is matrix. So dimension of column space is what? Spanned by this 1, 2 and 3, 2. And row space is what? 1, 3 and 2, 2. So dimension of these two is equal. If has dimension 2, then it also have dimension 2. But both will be span different spaces. This will span this column, and the row space will span the row of the matrix. So I hope you get it. If this question asks for the dimension of row space and column space are equal, then yes, it's correct. Dimension is equal. Okay. Get this point. Hello.
Yes, sir. Get this point.
Okay. Now the fourth one. If A and B are square matrix of order n, the rank of A is n, then both A and B must be invertible. Okay. So it is saying that A and B are square matrix of order n. A and B both are square matrix of order n, both n cross n. And saying that rank of A is n. Rank of AB is n. Then both A and B must be invertible matrix. So given this, and we are going to like it is saying that A and B must be invertible. These are the conditions built here. Both have n cross n and B is n cross n. Then and rank of AB is also n. So we need to so basically it is claiming that A and B must be invertible. Is this right? And is it right? So anybody, how to approach this question?
Sir, rank of AB must be less than or equal to the rank of A and rank of B, sir.
Okay. Rank of AB must be less than equal to minimum of rank of A, and rank of B.
And here is rank is N, sir. So it means N is minimum of rank A and rank B, sir. So both have the full rank, sir. And because of the full rank, nullity is 0.
Exactly. So rank of AB is n, and the maximum rank that rank A can take is also n, and the maximum rank that AB can also take is n. And so the minimum of n or n is basically, so I want to go from here to here, and I want to say that if rank of AB is n, then rank of A is also n. How? Basically, I just want to know that if the maximum that rank maximum rank that A have is K, suppose A have suppose, and if maximum B also have K because n cross n matrix, so K. And this K will be the maximum is maximum of rank A is n. The maximum rank that n can take is n. Maximum rank that n can take is n, and the rank AB already have n as a rank. Then minimum of this and this is n. Then it means that this is also n. So rank A is also basically rank rank of A is also n, and rank of B is also n. So it is basically vertical matrix. Understood this question? Question number 2. These are four column, four different concepts. Understood this part? Okay, this question is really important. This is really important, and you will write, and you will not get to know how to write, transform matrix. You will get to know like how to from matrix, how to write transformation, and from transformation how to write matrix. So read this question first. Can I start this question? Hello.
Yes, sir. You can go with.
Yes, sir. Yes, sir.
So this is linear transformation with matrix A represents some T with respect to domain and the coordinate. So it is saying that basically, that first thing is, so for a linear transformation, if we write matrix. So for a different order base, for different pair of order basis, pair means for a different order basis of domain and codomain, there will be a different matrix. Like if for these two order basis, the order basis for domain and order basis for codomain, we have this matrix. And if we get the matrix different basically basis, the matrix will be different. Like for this question is saying just change it. This was given matrix for this order basis, and asking for if this is order basis for both domain and codomain, what will be the matrix. So first we are going to try to write the transformation. How will transformation look like? So basically transformation is basically r square to r square. So dimension to dimension of the coordinate. So now we have to write the transformation. So okay. So what this mean? What this content of the matrix means? What this column of the matrix means? Anybody can tell that what this 3, 0 represent? And what this 1, 2 represent? Tell me, anybody? What the 3, 0 is representing in matrix A and 1, 2 in matrix in the column 2? So basically, it is saying that yes. So basically, saying that if you will take this 1, 1 ordered basis, first order basis of 1, 1, so you will the transformation will look like this: 1, 0 and 0, 1, and 3, 0 is given the coefficient. So 3, 0, and the transformation of 1, minus 4 will be 1, 0, the slight codomain, basis of the codomain, and write the coefficient from here, the C here, 1, 2. So write this. And now calculate. So for t, 1, the transformation will look like what? Basically, a standard basis for 3, 0. No change. So t, 1 minus 1. So basically 1, 1. Now these two are what? These two are basically we have taken the transformation of the, we have captured, not taken, we have captured the transformation of domain basis. So 1 comma is domain basis and 1 comma minus 1 is domain basis. And we know that if we know the dimension, if we know the transformation of the basis or domain basis, then we can write any dimension. We can write any domain vector transformation. Why? Suppose, tell me any vector of the domain, any vector of the domain, or any vector in the domain can be written as what? Can be written as this suppose 1 comma 1, any vector, like suppose x comma 1, can be written as 1 comma 1 and linear combination of 1 comma minus 1. That is the definition of basically basis. If you here coefficient and there will be coefficient. So any vector of this domain can be written as the linear combination of these two, 1 comma 1, 1 comma minus 1. Right or not?
Yes, sir, we can do.
Okay, so now we need to find the coefficient. What sort of coefficient we choose? So you can do calculation, and after 2 or 3 try, you will find. So as I have done before, so I know. So x minus y divided by, just divide by. And if you divide 2, then you will get x comma y, because x plus y 2 and x minus y 2, and x plus y 2 minus x minus x plus y 2. So this will come out to be x comma y. So I'm saying that you can write any vector of this domain, any vector of the domain space in this format, x plus y or x minus y, right?
Yes, sir.
Okay. Now, so, and now I have to take transformation px comma y. Px comma y can also be written as this one, this thing. I know as I derive it here. So can be written as x plus y by 2, 1 comma 1 x minus y 2, 1 comma minus 1. Now, since it is linear transformation, we can basically write it as x plus y 2 into t 1 comma 1 and x minus y by 2 to t 1 comma minus 1. Now, as I calculated earlier, the transformation of 1 comma 1. But it's okay, I erased that. So, what is the transformation of 1 comma 1? Is nothing but 3 comma 0. And what is the transformation of minus 1 comma 1? Is nothing 1 comma 2. This column. This column is why? Because this is a standard basis. If this is not a standard basis, you have to do like we have done. Now tx plus y, now tx plus y by 2. Now if you want to write the transformation, so you can write it as 3x plus 3y by 2 plus x minus y by 2 and 0, and then you will get x minus y by 2, so x minus y. And after computing this, you will get 4x and 2y, so 2x plus y and x minus y. So this is the transformation. We captured the transformation. This is transformation. This is transformation. How to, we have given this matrix and we have arrived at this point. How we calculated, this is important. So this matrix is given and we just calculated this transformation. 2x plus y, x comma y minus y. And this question is also in the second question, if you say, which of the following define the transformation of t? Then you have to like note this one, not this one. But the last option will be right. And this is the last option that we have calculated. Yes. Any doubt? Like this
So
is very
over
important.
here, how did you get
Yes.
how did you get 2x plus y and x minus y?
Okay. From a beginning, I have to explain, or just you have explain. You explain. Like,
Is just that part?
okay. So this part. So x plus like you can write x plus by 2 in 3 comma 0. Like we have calculated the transformation of 1 comma 1. So that comes 3 0.
Sorry, sir. I understood the calculation afterwards, but the
This
one that
calculation.
you've put in a box,
Okay, this calculation.
the calculation I understood, but the thing that you've put in the box, 2x y equals to 2x plus
Oh,
y, x
okay.
minus y.
This part you have.
How did you get the 2x plus y?
You understand this part?
Yes, sir, that one.
Okay, 3x plus
No,
y.
that is the part I didn't understand.
Okay. So basically, what I have did that. So we know that x comma y can be written as this. You know that x comma y written as this. Any vector of x comma y of the domain space can be written as this form in this form. Okay. And now we have taken this. We know that this since it is linear transformation, so we can like individually calculate that linear. So I have just factor out this constant part and transformation of 1 comma y, and then factor out this part and then transformation of 1 comma minus 1. Now transformation of 1 comma 1 as we have calculated earlier is 3 comma 0 and I put there, and the 1 comma 1 I put there, and x minus y by 2 is equal to this, and x plus y is equal to this. And now we sort of do all this calculation, and we arrived at this point. Let me repeat that part. Okay. So first, if you have given a matrix as given in this question, now for a given matrix, how will you arrive at a linear transformation? That's the main point that I want to say. How can we arrive from a matrix to a linear transformation? Okay. So if this is matrix, what now tell me anybody explain that. What does 3 comma 0 and 1 comma 2 represent? Anybody? 3 comma 0 and 1 comma 2?
It is a transformation of 1 comma 1 and transformation of 1 comma minus 1.
Since it is a standard basis, that's why. If this is not a standard, then it will be coefficient of this. Since this is a standard basis, so nothing will affect. Otherwise, if this is not a standard, if this is something, this is something, so this is basically represented 3. This coefficient, okay, is given there. Now, and that is this part. And so basically, we have calculated the transformation of 1 comma 1, like 1 comma 1 transformation, and then transformation of 1 comma minus 1. The transformation of 1 comma 1 we have calculated, and transformation of 1 comma minus 1 we have calculated. Now we see that how to write x comma y, any vector x comma y of the domain space in this basis. Okay, how to write this any vector of the domain space in this basis? How to write? What to write? What?
Sir, why that basis, sir? Why not that down codomain basis?
No, we have to take transformation from domain to codomain. No? That's why we have to write in x comma y in this basis, not this. We have to take from x comma y. We have to transform x comma y from domain to codomain. That's why we have to write x comma y in this standard in this basis, 1 comma 1 and 1 comma minus 1.
So if there in A in the matrix, if there was like a coefficient mentioned like x, y, and all, then we would have taken a standard order basis, right?
Okay, if in the matrix A it written some x, y.
Some coefficient x, y, and 2x.
What is x, y? Variable or constant?
Constant.
So,
Variable, you can say variable, right? It's a coefficient.
So x comma y means it means coefficient. So
yeah. So then we would have taken a standard ordered basis, right? 1, 0,
no,
and 0.
It will say like if you have to write this matrix, then it must say that this matrix is for this order basis and this order basis. Otherwise, it is irrelevant. If we say that this linear transformation of this matrix, no, that's not true. You have to tell that this linear transformation have this matrix corresponding to this order basis and this order basis. This is right statement. Okay, this is right statement. When you say that this matrix have this linear transformation of this matrix, then you have to mention the order basis of the domain and codomain. Okay. So basically, we have calculated transform 1, 1, minus 1, and we know we just learn to write x plus y by 2 into 1, 1, and x minus y by 2 to 1, minus 1. If you are wanting, just calculate this part.
Just a confusion here, Alok. So
Yes, yes.
why are we taking x plus y divided by 2 and then x minus y divided by 2?
Okay, just okay, just calculate this part, and you will arrive at this part. So you tell me how to write x comma y in this format. Let me. Okay. This x comma y. Okay. X comma y.
So there is no standard thumb rule. You just to get that 1 comma minus 1, you're taking that x plus y.
Okay, 1 comma
and x minus y.
Now in this box and in this box, what should I pick? So actually there is no standard rule. Like you have to calculate.
Understood.
If there is a standard rule, then this is a lot tougher. So you don't have, like, this is like small. So after 2 or 3 try, you will be able to calculate. So you have to put what should I put? Just you tell me. If there is an option available, I just try it and I put x plus y by 2 and x minus y by 2, and I arrived at that. If I calculate this, I will get x comma y. If you get another thing, if you put another coefficient, then that's also fine.
So here you're putting x plus y because there is 1 comma 1. So both of them are positive, then y is also positive. If I put 1 plus 1, 2 divided by 2 it becomes 1. Again we get the 1. And then in the next is x minus y, then 1 minus 1, minus becomes plus, and then you divide, then you again get 1 comma 1, right? That's how you coming like x comma y.
Okay, how I am coming to x plus y and x minus y by 2? Is this you are asking? Yeah. So I am coming after 2 or 3 try, not some standard method that I follow this, then I arrive at. No, you have to do 2 or 3 try, hit and trial, and you will arrive at that, because this is a small thing.
Okay, so somehow we just have to get that 1 comma 1. Or,
no, 1
sorry,
comma
x comma y.
Sorry, yes, somehow we have to write x comma y as the domain basis in the form of domain basis. Yes.
Yes. So can we write the x plus y divided by 2 and x minus y divided by 2?
Yes. Why I write that?
I was asking, sir, is the x plus y by 2 is an assumption?
No assumption. That's why I'm telling that this is 1 comma 1. And this is 1 comma minus 1. I am getting that if there is 1 box and there is 2 box. So in this 2 box, what should I write that I will get 1 x comma y? So by hit and trial, I arrived at this. X plus y by 2, x minus y by 2.
So it will help us understand better. Can you just expand that x plus y divided by 2?
I arrived.
Sir?
And then, yes.
Sir, a plus b equal to x and a minus b equal to y. Can we, after solving this, we get a value and b value, right?
What a and
that method? A into 1 comma 1 plus.
Let me express this. I am expressing this. Okay. Till this point, clear? No doubt. Like I am multiplying x plus y 2 into. Okay. Now I am going to add this. So adding this. One second. If this is like minus 1, then this is minus x plus 1. Yeah. Then this is minus y, and then minus x plus y, and this is okay. And then this part will cancel out. Then you will have 2x and 3. So this part will cancel out. Y plus y is 2y. 2y divided by 2 is 2. So you can look at this instead. Now it's clear?
Yeah, understood. Somehow you have to get that x and
yes, exactly. There are methods. but that method is not like a lot of like you have to find orthogonal and to do all this. So not so difficult. Like you will arrive by the practice, you will arrive, or hit and trial, you will arrive at coefficient of the matrix. Okay, so now I just express x comma y as this. Now that's the important thing. So x comma y can I also write this x plus y by 2, 1 comma 1, and x minus y by 2, 1 comma minus 1, just what I derived from earlier. This x comma y is this same thing, just from here.
Yeah.
Okay, now we know that this is linear transformation, so this part will come outside. 1 comma 1, right? Transformation of 1 comma 1, right? And this part x minus y by 2 also transformation of 1 comma minus 2. Okay, till now good. Okay, this part, any doubt in this part? Like
No.
Linear transformation, you know that. So now we calculated the transformation of 1 comma 1. We just calculate transformation of 1 comma 1. That is here from 30 and 1. 30 and 1. 30 transformation of 1 comma 1, 30, and transformation of 1 2. Yes. Now this do the same step. So you will arrive at 3x plus 3y by 2, and now comma 0 plus x minus y by 2, comma x minus y. Now you will have to do sort of things. Can I write directly? It will come out 2x plus y. If you add this two, you will 2x plus y, and if you add this two, you will arrive at x minus y. Now this is the thing that I transformation of x comma y is 2x plus y and x minus y. So we have given a matrix, and from this matrix we derive what transformation will look like. Transformation will look like this. Okay. Any doubt? You will get this question.
No, understood.
So now transformation of 2x plus y, x minus y. Okay. So the matrix can be different. I said that matrix for an ordered basis, like for an ordered basis is different. Like for this ordered basis, the matrix is this. And now the question is asking, if I take the order basis, standard order basis for domain and codomain, what would be matrix? Matrix could be different, but transformation is different. No, transformation would be same. Transformation will be same. The rank is same. The column is same. Rank is same. Null space is same. So, like for this ordered basis, the rank will be whatever null space. For this also matrix, rank and null space will be same. So you calculate from any matrix. Another thing I have to calculate is that. So I have solved this part. Which of the following define the transformation of T? So this is transformation of T. Okay. 2x plus y, x minus y. Now I have to get from transformation to matrix. I just arrive from matrix to transformation. Now I have to transformation to matrix. So we know that transformation is 2x plus y, x minus y. Now in this question is saying that if I take a standard order basis for the domain and the standard order basis for the codomain, then what will be the matrix? Now listen. So first take the domain basis 1, 0. So if I take the transformation of 1, 0, what it would look like? This 2 and what? Tell me 1, 0 transformation of 1, 0 is what? 2 and 1, right? Transformation of 0, 1 is what? 1, 0, 0, is the basis that I have to take, standard basis. So it will be 1 and it would be minus 1. Now this is the transformation and this is the transformation of 1, 0 and 1, 0, 1. Now transformation of 1, 0 I know 2, 1. Now how to write 2, 1 in 1, 0 and 0, 1? So because this is also you have to write. So you can write simply 2, 1 and here 1, minus 1. This is true only because codomain is a standard. If codomain is not a standard, you have to do same thing and you have to figure out the what coefficient and then you have to write in the column 1, then you have to write in the column. Since it is a standard basis for the codomain, so you can simply write 2 comma 1 here and 1 comma minus 1. Get that? From transformation, I get matrix. If in the first question, we have get a matrix, we have get transformation from the matrix. In the second question, we have get transformation from the matrix. Understand this part, this question? Any doubt?
Sir, we can use another method now if we find this 1 0 in terms of uh, above 1 comma 1 and 1 comma minus 1 and then find the transformation of this.
No, tell me your approach. What you are saying?
So I am saying in the question, sir, in that question, in last question, which of the following matrix is no, sir, above question, sir. I am saying, sir, here is the basis now 1 0 and 0 1
Yes, yes,
for
yes,
both
yes,
domain
yes,
and codomain. I
yes.
am saying if I write 1 comma 0, 1 comma 0 of this in terms of 1 1 and 1 comma minus 1 and then find the transformation of this like that.
So
Then I
you
can
said
find the transformation of 1
you
0.
write
No?
1 comma 0 as a 1 comma 1 and 1 minus 1.
Yes, sir, in terms of, and then I will get from here I can get the transformation of 1 0. Na?
So this is what we do x comma y. In the first step, we do x comma y to calculate transformation x comma. You are choosing particular vector. You are choosing what should be the particular vector 1 comma 0. I am generalizing. I am taking for any x comma y. Understand that?
Okay, sir.
I have taken for any standard x comma y. So for 1 comma 0, and you have to write this. You have to write this coefficient. You have to find the coefficient with the hit and trial method. And playing with the number is easy. Compare with the alphabet. So you can find easy, and you can do all sort of things. And from here, you can go here.
Sir,
You can go here.
if in question it is written that 1 0 and 0 comma 1 for both domain and codomain, but what if the basis for the codomain is different in this question, sir?
In this question, is
Yes, sir. If
is it?
yeah, it is for both now, but if the basis for codomain is different, then what?
Okay. So 1 comma 0 transformation arrived 2 comma 1. Okay, we arrived at 2 comma 1. Okay. Now,
Guys, if you have
yes.
any doubt, just raise your hand. Alok sir will be ask you doubts after completion of question. Then you will they ask them.
Okay. So uh, listen. So 2 comma 1. If you arrive to 1 comma 0 and 2 comma 1, what if codomain is not a standard basis? That's what you are asking. So you have to write this codomain, and you have to again check by hit and trial what would be the coefficient. And if the coefficient you find, you will put in this column 1. And for 0 comma 1, you will have to 0 comma 1 is 1 comma minus 1, and you again have to find this coefficient, and you will put in the column. Get this? You have to find the you have to write the coefficient. So this matrix A contains the coefficient. Okay. So understand that.
Okay, understood, sir.
Understand that. Now the most interesting part of this question. We will get the. So just two questions like rank and nullity of transformation. So if you have two matrices. Okay. So I will let about. So you have two matrices. You have matrices this A 3 comma 1 and 0 3. This is the matrix of linear composition. Just calculate rank, that will be rank of T. Just calculate null, that will be the null of T. So rank of T is what? 2. Null of T is what? 0, because minus 2 is 0. And this is the rank of T and nullity of T. So you can expect this question. This kind of. So nullity of T is 0 and rank of T is 0. Okay. So So nobody raised hand. So can I continue or like in the middle? Hello, Laksh. If you have any doubt, just ask me. Like I have to in this one.
Sir,
Yes.
sir, can you assist me with graded assignments, sir? On small doubt.
Yes. Yes.
Graded assignment week 8.
Credit. So please share your screen. I don't know.
One minute. Sir, is my screen visible?
Yes. Yes.
Eighth question, sir.
So
Can you please explain how that a transformation x comma y is equal to a divided by root of a square plus
let
6
me
square?
answer inner product specifically. If it is a orthogonal linear transformation, we'll find the value of 19a plus 16. So this is okay. Can you zoom question? Yes.
Is it okay now, sir?
Okay. Okay, so inner product of the Pythagorean and linear transformation define Txy is equal to if T is orthogonal linear transformation, then find the value of 19. So basically, you can okay. So you just take two bases, 1, 0 and 0, a standard basis. Okay.
Okay.
And then calculate its basically whatever from a standard basis 1, 0 and 0, 1, whatever the like transformation comes, just do dot product because suppose so it may seem visible.
Sir, what do you mean? I couldn't hear.
A screen visible, my screen.
Your screen. 1 second, I'll switch. No, sir, your screen is not visible.
Okay. So I just am telling that to just take the transformation of 1, 0.
1 second, sir. I will stop my sharing instead. Okay.
Okay.
Shall I stop?
Yes. Okay.
Yes, sir. I have stopped.
Don't. So I just lose question. So how to know? Can you calculate, like, I can assist, like you calculate the linear transformation from for 1 comma 0 and 0 comma 1 and tell me.
Sorry, I couldn't get it. What do you say?
Just calculate linear transformation for 1 comma 0 and then 0 comma 1. Calculate linear transformation.
Sir,
Yes.
now I'm unable to calculate as I don't have any pen and paper with me. Sorry.
Okay. So
You just give me an idea of how to solve that sum.
so
Because
what I'm saying, that just take the basis of take 1 comma 0 and project take linear transformation. So you will arrive at a vector and take another basis 0 comma 1. You will arrive at another vector and then take dot product of these two vectors. Get that point?
okay.
And then you will arrive at the point, because these two are orthogonal. So the when you take dot product, then it will be achieved. Okay.
Okay, sir. Okay.
That's what I'm saying.
Okay, thank you, sir.
So I'm ending the meeting. Okay.
Thank you, Alok sir, for their coming.
Thank you so much, sir, for your presence. Thank you.
Thank you guys for joining us. Happy learning.
Guys, the session has been over. You may please leave now.